Hello viewers, welcome to my YouTube channel VK Civil Hub. Myself Professor Vinod Kumar, Department of Civil Engineering. In today's video, I am going to explain two problems on stresses and strains along with two practice problems for you. In order to understand this problem, we need the basics. If you haven't watched my previous video on this basics, please watch it. I have given the description in the link below. Let's get into the video. The first problem goes like this. A steel rod 150 cm long and of diameter 2 cm is subjected to an axial pull of 20 kN. If the modulus of elasticity of the material is 2 into 10 power 5 Newton per mm square, determine the stress sigma, the strain E, and the elongation of the rod delta L. Before working out the problem, please don't forget to convert all the units to one particular unit. Here we are converting it to Newton and mm. All are SI units. Okay, let's see what's the given data. Length of the rod L is given as 150 cm. We are converting it as 1500 mm. And the diameter of the rod D is given as 2 cm. It gets converted to 20 mm. Axial pull P is given by 20 kN. It's converted to 20 into 10 power 3 newtons. Modulus of elasticity capital E is given as 2 into 10 power 5 Newton per mm square. So these are all the given data. With the help of this, now we are calculating the area of the rod. Since the diameter is given, this steel rod is a circular rod and we are calculating the area of the rod as A is equal to pi by 4 d square. That is the formula. So here the value of d is 20. So pi by 4 into 20 square gives you 314 mm square. Here in this problem, we have to find the stress sigma, the strain E, and the change in length delta L. So let's get into the first part to find the stress in the rod sigma. We know that the formula for stress is sigma is equal to P by A. The value of P is given, the value of A is calculated, and we are going to substitute both the things here. That is 20 into 10 power 3 divided by 314.29. And we are getting the answer as 63.64 Newton per mm square. Now the second part of the problem is to find the strain in the rod E. Here in this problem, delta L is also asked to find. Okay, so we don't have the value of delta L and we have to find the strain, means we have to use the Hooke's formula, that is E is equal to sigma by E, that is stress by strain. So from that formula we get strain is equal to sigma by capital E. So sigma is already found as 63.64. We are going to substitute it here and the value of E is 2 into 10 power 5. So we get the answer as 0.000318. Next, the third part of the problem is to find the elongation of the rod, that's delta L. Here we can use the strain formula because the strain value is already found. So we are going to use E is equal to delta L by L. From this formula, you cross multiply and take the delta L to the other side. We get strain into length. So the strain value is 0.000318 into length value is 1500 mm. So the answer you're getting is 0.477 mm. So the problem is over and the results are sigma is equal to 63.64 Newton per mm square. Strain E is equal to 0.00318 and the change in length delta L is equal to 0.477 mm. Change in length and elongation are both same. Now let us see what is the second problem. The problem goes like this. Find the minimum diameter of a steel wire which is used to raise a load of 4000 newtons if the stress in the rod is not to exceed 95 meganewton per meter square. So in this problem there are only two given datas. In the previous problem and this problem both I have mentioned the given data in the question itself in the green color. You can easily differentiate that. Now the given data is, one is load P is given as 4000 Newton and the stress sigma is given as 95 meganewton per meter square. Not to exceed means we have to take that value in the problem. So this unit meganewton per meter square is equal to newton per mm square. This I have explained in the previous part in my video. You can check it once again in the link given in the description. So this 95 meganewton per meter square gets 95 newton per mm square. I will explain once again. Mega value is 10 power 6, and the meter, if you convert it into mm, you get 10 power 3 mm the whole square. You get 10 power 6 mm square. So this 10 power 6 and 10 power 6 in the numerator and denominator get cancels, and you get the value newton per mm square. So the answer is the same, 95 newton per mm square. Here the question is to find the diameter of that steel wire. Okay, so we are going to use sigma is equal to P by A formula, stress formula. Sigma is given as 95, P is given as 4000. Here the area is not given, no? So we can't find the area using pi by 4 d square. So substitute the value of A is equal to pi by 4 d square here and take that d square to the other side. So what happens? We get d square is equal to 4000 divided by pi by 4 into 95. We are taking d square to the other side and bringing the 95 to the denominator. So again it gets 4000 into 4 divided by pi into 95. This pi by 4, no, that 4 goes up on the numerator. So we are getting d square as 53.61. How to find d? Take square root on both the sides. So we get square root of d square as d and square root of 53.61. So d is equal to square root of 53.61, and the answer we are getting as 7.32 mm. This is the final answer for the question. This is very simple problem. I mean, the first problem and second problem are very basic problem. In the next video I will be explaining you a bigger problem wherein we have lot of given data and lot of data to be found. So based on these two problems, as already told you, I will be giving two practice questions. This practice question one is, it's a brass rod, the diameter is given as 25, length is given as 250 mm, P is given as 50 kilonewton, delta L is given as 0.3 mm. Here you have to find the Young's modulus capital E. So here I have given the hint for you to work out. Convert all the units to Newton and mm. Second thing, find the area using pi by 4 d square. Third, find the stress using sigma is equal to P by A. Find the strain using E is equal to delta L by L. Finally, find the Young's modulus using the formula capital E is equal to sigma by E, that is stress by strain. And the answer you are getting is 84,883.33 Newton per mm square. So this is for you guys to work out as a practice. The second practice question is, it's a rectangular steel rod. Its length is given as 500 mm and the rectangular size is 20 mm by 10 mm. The load given is 300 kilonewton. Young's modulus or modulus of elasticity capital E is given as 2 into 10 power 5 megapascal. Here also I would like to mention megapascal is equal to Newton per mm square. So the question is to find the stress sigma, strain E and the elongation of the rod delta L. Once again let us see the hints for this problem. Convert all the units to Newton and mm. Find the area using A is equal to L into B because it is a rectangular section. Find the stress using sigma is equal to P by A. Find the strain E is equal to sigma by E. That is from Hooke's law. Okay, cross multiplication. Next, find the change in length using strain into length. Here both are not given, no? So we have to find out. And use 1 megapascal is equal to 1 Newton per mm square. Both are having the same value. So for this problem you are getting the result as sigma is equal to 1500 Newton per mm square. Strain E is equal to 7.5 into 10 power minus 3. And the change in length delta L is equal to 3.75 mm. Please take this problem as a serious one, work it out, get practiced. Practice makes a man perfect. Thank you. Okay viewers, thank you so much for your patience. Let's meet in the next video. If you like this video, kindly subscribe to my channel VK Civil Hub, or you can contact me through vinodkucivil@gmail.com, and also you can comment in the comment section. All the comments are welcome. Thank you.